Okay, let me explain a little bit about it. I cannot give you the whole detail information, but one thing bothering me in the beginning is the metric is defined on a set. And what's the elements right now when you define the metric? They are the real numbers, right? So the meaning is this metric is defined on uh, R2, or exactly just R. Okay? So you don't need to redefine or need another new set like this, right? No, actually we are just talking about a new metric, new way to measure a distance on real numbers, right? So if R is alone, that's just alone a set, but it can be equipped with a distance, right? A metric, okay? And that metric could be anything. A lot of different ways to do that, and this is the one, right? So you don't need to say this, or you shouldn't say that way. Okay? So you just simply say this is defined on R. Okay? And if x, y is equal, then there's 0 and like that, right? So uh, I suspect you might say this because it looks like it's order pairs, right? It's not, you can say that, right? It's like R squared to uh, R, okay? And eventually it's non-negative, right? But so that's the way you can define a metric, okay? So you pick 12 to real numbers here, right? So eventually, but altogether, eventually you're just measuring a distance between that two real numbers, right? Okay. So either way, you want to put that, it's okay. But key point here is you don't need to make another set, right? That's the one thing. And the way you prove the first part, yeah, that's the way you can do that, right? And in the second part, I understand, I believe you might see this in other math course, right? But right now, yeah, look at here. Uh, d of xy is not an element of real, it's a real number, right? So you can say like r, right? Instead of a, it might be possible to do that, okay? But the meanings are a little bit different, so it's kind of dangerous. If you understand it, then you might use some different ways to say, right? But most likely, I don't recommend to say that, right? So how can you say that? Suppose there is a very specific element, right? X and Y, right? And so like suppose that there is very specific X and Y in R, right? Such that dxy is 0, but x is not equal to y. Okay. Then that dxy should be what? By the definition of dxy, right? If they are not same, then it should be 1. So it's against of that hypothesis, or when they define the d, right? It's contradict to what? It's better to say, right? Therefore, dxy should be 0 if x is not y, if x equals y. Okay? So still, it's not that clear. Okay? I believe you just kind of take a negation of one of the condition, right? Okay? And assuming that, then it's against with something here, right? Because you're kind of using this one and to prove itself, something like that, right? So, and I don't want to recommend that way, right? So please thinking of a different way. Okay? It's going to be very similar for that, but okay. So like that. So I believe second one. Oh yeah, the third one. xy and yx should be same, right? So it's according to the definition, right? So if you say like that, then it's not 0. So x is not y. You can say that, but by the definition, then you can just simply go to here, right? Directly. Then that means what no, this one the ball, okay? No, not like that. So it's like this. The condition 3 says we always get dxy is same as dyx, right? So the first thing you have to say is, okay, dxy is 0, right? And by the definition, xy must be same, right? Then that means y equals x, right? Then by the definition of d, you can say dyx equals also 0, right? So can you see what's going on? It's like we want to accept the kind of commutative to put these two real numbers for the metric, right? And eventually you want to prove we can do that, right? It doesn't change the value, right? The metric, okay? Even you change the order. Problem is, we don't know whether we can do that or not, right? For this new metric or pseudo metric. So you have to prove it by what? Changing this, which we don't know that much about it, to something we know. This kind of equivalent statement is what? That to the real numbers are equal, right? Then in this case, we can commute, right? X equals y equals x, same thing. Then, because of that order, and by that definition of d, if y equals x, then we can say dy comma x should be 0, right? And then we can claim, oh, therefore, these two values are same. And the second choice is for 1, right? So it's a very similar way to do that, right? Like that. So I wonder how many math courses you took before, right? But it looks like you might need some more practice about it. Okay, xyz, dxy, dy, yz, yeah, same thing. No, it's not 8. And at this moment, we know that no matter what x, y, y z we choose, it's either 0 or 1, right? Not less than greater than, right? So some must be okay. And definitely so. That one, no, we cannot say that one yet, because if you accept what it says here is, then we still have chance that some of these two might be equal 0, right? But dxz might be 1, right? Then still dxz could be greater than the sum of these two, right? So you don't get any result yet, right? So far this much is okay, but so please rewrite this one again. And if you have any question, please come by my office. Okay? I might be tomorrow around 11 to 1 or something like that, right? Or Tuesday, yeah, I might be in my office, okay? But to be open today or whole day. Okay? Or just call me before that, okay? And make sure that I'm there. But hopefully this is helpful, okay?